Thank you. Hey, no worries. It'll give me the ability to stand out of the light up here.
Okay, why don't we go ahead and get started? Welcome everyone. This is the usual Thursday noon research conference of the Department of Medical Informatics and Clinical Epidemiology, and I look around and actually I see some old faces, but I also see a bunch of faces I don't know, which is a good thing. It means we've gotten the word out and have gotten a lot from around campus to show up. In addition to being our regular research conference, this is also one in a series of a new initiative that we've undertaken in the department that some of you know about, called the Informatics Discovery Lab. And the goal of this initiative is to try to build partnerships with organizations that are outside the usual academic sphere, at least for us, certainly not other universities. But and a big part of that partnership is with industry. And so we've reached out to a number of industry partnerships, and we've happened to been delighted to discover that IBM exists in our own backyard, even though, as our speaker will talk about, it's truly a global and virtual company. But there are some people who actually live in Oregon, and one of those is our speaker today, Steve Miller, who is Program Director of IBM's Information Management Practitioner Marketing Team. And so he's responsible for their Big Data and Analytics Professional of the Future program, which I know that at least those of you in the room who are students in our informatics program are thinking about your future as data and information professionals. This program that Steve leads collaborates with universities around the U.S. and the world to develop the strong pipeline of talent needed for the next century, with a focus on data scientists, information architects and strategists, data policy professionals, developers, and informaticians. I actually added that last one.
Cool.
It wasn't on the form here. But anyways, so Steve's going to tell us what those of you who are students need to know about data, and what those of us who are faculty need to know about, so we can best educate you and those who follow you. So I will turn it over to Steve.
All right. Well, thank you. All right. So I just kind of curious who the audience is. So how many people here are undergrads? I didn't see a lot of hands. So everyone else that's a student is in a graduate program? And the rest of you are faculty or other roles? Researchers? Okay. Business systems analyst. All right. Cool. All right. Well, thank you. All right. So as he said, I'm from IBM, and I happen to live in Portland, or actually Beaverton, but I make this my home, and I lived here since '98 and absolutely love it. And it would take a lot to get me out of Oregon, because I think this is really a fantastic place to live. So I'm here today to talk about some work that I've been doing around a broader set of careers around data. And I don't have a lot of specifics around health informatics. I actually have kind of an empty slide that maybe we can work on together to fill in, because I'm learning from your faculty here today. So let's move to the first slide. So how many people here have heard about the term data science or data scientist? Most times, right? And there's one of my favorite was this Harvard Business Review article, "The Sexiest Job, right, of the 21st Century." Right? I think that's a pretty cool idea, and because this is a new role that's emerging. In a lot of ways, it's not any different from what you're studying here at the school. It's just a more general application of it, and it's a job that's growing. This is Indeed.com data. So if you've ever used Indeed.com as a job hunting engine, there's a trends on the first page. You can click at the trends, and you can type in keywords, and it'll show you, what is the trend of that keyword showing up in job postings. And for whatever reason, it always tends to trend down at the end of the year. So you always see these weird. I don't know, maybe it's just the way jobs get posted during the year. But you can see that it's a pretty solid, percentage growth rate, right? At times, almost 100% growth over the previous time. So it's a fast growing. But I'm going to show you one coming up that is much, much faster growing than this right now. This may grow faster in the future, but right now it's growing very healthy. It's a new career field. And we're finding that so far, there's only a handful of schools in the country that claim to have a program to create data scientists. Not that they don't already exist under other names, but this is a new name, a new concept to a lot of people. And it requires a bit different thinking about what does it mean to be a data scientist? What are the skills? And I'll have a slide coming up in a bit. We'll start going into a little bit about what are the types of skills that a data scientist needs. Let's go to the next slide. So here's another one. Here the growth rate's much more significant. This is the emerging role of the chief data officer. And you may think, well, I've got a CIO. Isn't that a chief data officer? And the answer is no, right? So a chief data officer is actually focused on all things data. What are we going to do strategically with our data in our company to make our company more competitive? And some companies are architecting their entire business model around data. So I imagine everyone in here has used Yelp or used TripAdvisor or used all these, where these are companies that are based on data that's curated by their customers, and they just provide an engine to do that. That's their business model, right? They'll sell advertising and other things around it, but it's the data, right? I'm a big Foursquare user. Again, I'm self-curating all the data that goes into Foursquare. And so I'm sure there's people in here that are using other similar types of sites, right? There's one called Untapped. I'm a beer drinker. So with Untapped, I can enter the beers that I drink. I can check into them. I can share it with my beer friends. Right? This is just the beginning, right? And it's integrated with Foursquare. It's integrated with Facebook. I can post it and share it everywhere. There's a whole new thinking to a lot of things about data and the pervasiveness of data. And then these new concepts of, quote, big data, that are causing companies and government organizations and individuals to think differently about it in ways that we've never had to really consider before. It was something that some geeks in the IT office took care of. But now it's something that actually affects everybody. And that's a really important point that I really want to make in today's talk, that data really does affect all of us. And there's actually a core, what I call literacy around data that everybody needs to have. You just start thinking about your personal data that you're putting on LinkedIn or you're putting on your Facebook page or Twitter, right? And how you manage and present yourself to the world, that's a form of data, right? And your reputation is kind of built into that. And it's causing all of us to rethink this. And there's companies out there, IBM included, that are using all the information that we're voluntarily putting onto these sites to make business decisions. So companies are understanding, like there's companies out there that are focused on like apparel. And they want to figure out, so how do I need to have next quarter's fashions figured out. What should I do? Right? And so they can start looking at people's Twitter feeds and make smarter decisions faster about what they need to do differently with their product line, just based on all the data that you're all curating for them. It's really up to them to figure out how best to do that and to get it right. And there's also cases in the healthcare world, I believe, where I think anybody else that read this one, I hadn't delved too deeply into this story, but there's actually some studies done where they're using Twitter feeds. Local public health officials are able to find out faster whether there's a flu outbreak in their city. All right, that's pretty cool, right? So data is just changing everything, and that's why you have this need for new job roles, maybe at a higher title, maybe not somebody hidden in the company that's going to go do this for everybody. And why you need a chief data officer, for example, that's sitting on the corporate board next to the CIO, the CFO, the CIO who's managing, do everything networked together. There's a laptop on everybody's desk and so forth. But taking a strategic look, and you can see the growth path here, 200% in recent quarters, right? That's pretty significant. So far, much faster than data scientists. So data scientists may completely surprise us and grow even faster over time as it grows from beyond it's the current fad word of the moment to something that everybody's actually doing. Next slide. All right, so here's the surprise. Data policy jobs is actually the fastest growing data role by a wide margin. And I'll explain what I mean by data policy in a minute. But if you start looking at this, so here's the data governance. So jobs that have data and the governance of data, somewhere in that job description, 600% job growth. Look at this one, data steward, 1,500% job growth. Who knew? I didn't even know until I went and looked at these data, right? And the interesting thing is try to find a school that's teaching this in any really concerted way. And it's really hard to find. But yet this is where the jobs are. And this is, why are these jobs here? Everybody, whether you're working for a government, whether you're working for a private company, has to deal with how am I going to manage this data? Who's going to get access to it? How are they going to get access to it? Am I in compliance with local laws and regulations, federal laws and regulations? Do I have a privacy policy? Am I obeying that privacy policy? Right? This is a huge time sink for companies, and they're out looking for skill everywhere. They're hiring people and training them themselves because nobody's yet, at this point, is teaching this in any concerted way. Now, I don't want to take away from the schools like the Syracuse iSchool that do have a sliver of their program focused on some of these things. But they're not really focused yet on these broader issues. And one of the things that I've been doing, working with schools, is going, hey, you want to create the first data policy program in the country? Partner with IBM, right? So maybe OHSU can do that. Yeah, so this is, because this is, the embarrassment often happens around doing this wrong. So a gentleman I just met who actually lives in Portland wrote a book on the ethics of big data, Cord Davis. And I read his book, and I found his email address. Oh, wow, he lives here in Portland. So we met for a beer. Now I'm actually going to bring him to our conference in November to teach a tutorial on how to handle big data ethically. How do we manage that as an organization so we actually have a structure around that and try not to embarrass ourselves? Because embarrassing yourself is remarkably easy in ways you might not expect. So how many people heard about Target last year getting themselves in a lot of hot water publicly because they made it aware that they were offering women things based on the fact that they figured out they were pregnant based on what they were buying? Right? Oops. Right? Because maybe you didn't want to do that. Maybe you needed to think about what would be the negative reactions of us taking those types of business choices. And that's just, I think, just the beginning. I think that's why this area is actually going to continue to be the fastest growing area. Because every company impacts it, right? In some cases, you can, data scientist, we can go subcontract that out, bring somebody in to help us figure it out. Or we can hire and use all these startups, Keen.io, blah, 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 blah. There's 1,000 startups all giving data science services in the cloud. But at the end of the day, you can't really outsource data policy. You've got to do it yourself. All right. Next. So this one is a little bit too wordy for the bigger room. But the key idea here is that data skills are needed everywhere. And it doesn't matter what you're studying, you need to know about data. You need to have some core analytical skills, because every job in the future is going to require some core literacy into those ideas. And we're already seeing specialties come out. There's lawyers. There's actual practices now that are emerging that are focused on data law. There are not very many of them, but I think as all this continues to accelerate, we're going to see a lot more specialization in things like data law. Open data in government. So Portland is on the forefront of open data in government. And there's going to be on June 1st a hackathon in the city here that's sponsored at Thetis Corporation, a small company in the Pearl. Actually, not in the Pearl, Old Town. And I participated in this last year. I'm hoping to be there again. And the whole idea is what cool things can we do with open data, government data, build apps, do things with it, fun, right? So hopefully we'll see some of you volunteering for that one. And if you want, I'll give you my Twitter ID and you can ping me later. And in my stream and my Twitter is how to sign up for the hackathon. So business schools, probably the fastest adoption it's just amazing. It's hard to find a business school in the country that's claiming not to have an analytics program. So I don't think we're going to have any shortage of business people with core analytic skills. The real shortage is going to come in the skills everywhere else. There are programs like here on the health informatics side that are going to fill that need. But it's all the other fields are going to need competency of data. How do I work with data? How do I analyze it? How do I apply machine learning? How do I visualize it? How do I do all these things with data? Where are those skills going to come from for those fields? Right? That's really the big challenge for us right now. And that literacy piece is something that I think is really important. And so data literacy and analytics literacy, and that's a decision I think schools are going to have to start making. Are we going to have, how should we structure that? One idea I have is that maybe you should have a course during every year of your 4-year undergrad. And as you progress, it gets deeper. So your first year, it's a basic core literacy and how information systems work, and how do you interact with social, and how does that impact. The next year, maybe it's a more focused course on analytics, probably the basics, right? You got to learn a little bit about, before you can go to the next level of analytics, you got to understand statistics and probability and some of these core pieces. Your junior year, it's more focused analytics. Then your senior year, it's probably something tied directly to your field. How do I apply analytics to the field that I'm studying? So that could easily be 4 courses. But that's not easy to change in a lot of school systems. To add, if you're going to add 4 required courses for every student to take, what comes out? Right? That's a big challenge for faculty members all around the world. And then today I was learning about health informatics here at OHSU. It's an area that I personally have not spent a lot of time on, so I'm learning from you today. And I think that we're going to see not just bio or health informatics. I think these are going to emerge in pretty much every field over time. And I think it would be interesting if we could just maybe do some prediction software to figure out where will be the next 2 or 3 of these specialized informatics types of programs starting to crop up around specific fields. Have a seat. All right. So any questions at this point?
Let's see. Could you push, just for people who ask questions, if you could push the button on the thing that we're recording this at? No, the button here. Yeah, and hold it down. Yeah, hold it down while the light's on.
Okay. On your slide here, you have data literacy and analytics literacy. I think I have a kind of vague idea of what the difference is, but could you verbalize it for us?
Sure. Data is just really the underlying pieces of information about how do we manage the data itself. So it could be as simple as understanding the data is going to be on your phone, or it's going to be on your computer, or in some cloud server, and understanding the ramifications of all of that without actually even thinking about analyzing it, right? All of us are wrestling with that every day and making choices about it, sometimes good, sometimes bad. For example, I'm a big Evernote user, and I was just thinking last night, gee, why isn't there a pin on my Evernote? Somebody grabbed my iPad, they could be looking through some stuff they probably shouldn't be seeing. And then, they're charging for that. So I have to go and pay for that. But that's another element of data and the security of data and how you manage all that I think is going to be important to everybody, whether it's your individual or whether it's your organizations that you're working for or organizations you're volunteering for, your government. All of that about how this data is managed and shared is something we all need to have a fundamental understanding of how that works. Whereas analytics is much more focused on a lot of other concepts. Okay, now that data is there. Now what do I do with it? How do I think about it? Can I make predictions from it? Can I automate decisions? Decisive or decision analytics is an emerging field. A lot of companies are automating that, making decisions on the fly. Oftentimes when you go do a loan application these days, they're making a decision for you like that. But there's a lot of math and a lot of things in the background that all fed into them being able to do that. And I think that's going to happen probably in healthcare as well. A lot of decisions are going to be made by the software. And when do you have to decide, the software can't make this decision, and we got to have a doctor come in to validate that that's the right choice. I think it's a lot to We don't know yet. But decision analytics is a huge burgeoning new area.
So if you're going to answer this question later, I guess you can skip. But this might appear a bit pointed. I guess I'm curious, what does IBM hope to get out of pushing this data literacy and an understanding of data stewardship?
Well, I think it's really quite simple. Anytime a corporation is pushing anything like this, there is a fundamental belief that we will profit as a company in the long run, right? But also IBM has a different view on a lot of things, that there actually is a societal benefit to a lot of things. So we have this, how many people have heard about IBM Smarter Planet advertising or any news about Smarter Planet? We're making a lot of investments in cases where we walk into a city with a team of IBMers at no charge to the city to help them wrestle with a local issue, which could be water supply issues or traffic congestion issues. And so IBM, as part of our corporate branding and position, is that there's a lot more that we can do to support all of these. And another example, and I was going to use it at the end, but let me give it now. So we have a IBM volunteer program where I can go into the system and create a volunteer opportunity for others within IBM to sign up and do. And I just created one within the system in the last 2 weeks to take advantage of an opportunity here in the city of Portland. So one of the realities in Portland from an educational point of view at the high school level, and how many people would guess that if the number of high school teachers that can teach computer science in the city of Portland, how many of you would say 10 or more? Pretty good. How many would say 1? That's the right answer. 1. So this is something that we're working with the Technology Association of Oregon, Tech Oregon, to create a program to work with high school students. So next Saturday, March 18th, if you want to come and volunteer or be a part of it, there's an opportunity for anybody that's interested in helping build STEM schools, skills in Portland schools, to volunteer. And again, that'll be the information about that in my Twitter feed. But I think there's another opportunity about volunteerism, right? So IBM is helping foster IBMers to volunteer, but I don't want it to stop there. But I think anybody that cares about Portland kids and cares about education, there's an opportunity for you to be a part of that, to help make that happen so that we, as experts, can be mentoring kids and helping the schools overcome the reality that there's only one computer science teacher in the whole city. All right. Any other questions? All right, next. All right, so I'm going to go into some more details on 4 roles here. So data scientist. Next slide, please. All right. So the data scientist, to me, this is the curiosity position, right? It's like you approach every day with going in about what questions can I ask? How can I help my company or my government or succeed at doing something that they weren't doing before? And this is a discipline that incorporates a lot of different skills. It incorporates some of the literacy that I talked about data and understanding data strategy. You need to understand the governance of data. You need to understand ethics at a basic level. It may not be your day job, but you need to know those basics. You need to understand all 4 areas of analytics, from descriptive to predictive to prescriptive to decisive, right? So these are, we've been done a lot of work over the last few years to kind of give more precise definitions to each of those 4 areas. And a number of IBM schools that we're partnering with at the business level are actually building their programs around those 4 concepts. Knowing how to visualize data. But what really differentiates the data scientist, from my view, from a business analyst is that the data scientists are going to have to be hardcore techies in a way. They're going to have to understand, especially with today's technology, they're going to have to know how to program a computer. How are they going to do a MapReduce job? How are they going to use Mahout to do machine learning? How are they going to do data mining? They're going to have to understand lots of basics about the technology and be able to actually code and do it. We may get to the point in a few years where the tools get developed for the data scientists, so it becomes more of an applied job. But today, these jobs are very much hands-on. You better know your stuff from a deep technical level to do this, to take use of what's there. So we're seeing a lot of emerging job titles: data scientist, decision scientist, analytics specialist, predictive modeler. We're seeing people emerge with fields in data visualization. So if we go up to Vancouver, not the immediate one here, but Vancouver, Canada. So there's this school there, Simon, I'm forgetting the last name part of it. Yep, Fraser, right? They've got one of the leading programs in the whole world in visualization and analytics. And those programs that are creating and starting to fill the need. But there's a few others out there that are specializing, building that kind of skill, but not very many. But visualization, I think, is really important. Machine learning. So in the mid-'90s, I was working for a startup in Wisconsin, and one of my coworkers, we both left. He went back to Urbana-Champaign to get his PhD. I mean, we just recently crossed paths. So where did he get his PhD in? Machine learning. So, and where is he living? He's living in D.C. He created the data science meetup group there. How many people here use meetup.com as another online way? All right, it's a few. And so he's got 1,000 people in the D.C. area that care about data science. And every month he's organizing meetups, bringing people interested in the topic, bringing in speakers from Google or IBM or others to come and talk about and get a discussion going. So it's really cool, right? So all of a sudden our careers came back. Small world. Computational scientists. These are just a beginning, I think, of all the different types of titles. So we're working with a couple of schools at 2 different levels. And actually, there's a lot longer. I'm just using 2 examples. So the Syracuse iSchool in New York, they've created a data science certificate program. And Northwestern in the Chicago area has created a Master of Science in Analytics run out of their engineering school. So these are much more technical than the business programs that I talked about earlier. Any questions? All right, next. All right, so the Chief Data Officer. I put a question mark here on where are these skills going to come from? Because so far I've not seen a program that's really designed as to create those types of skills. I think there's schools that are close, but none that are really saying that it's our job to create these types of skills. There's a lot of MS and information systems courses out there where your first job might be a data architect, a data engineer. But when I look at their curriculum, I don't see them addressing the top of this chart. I see them data strategy, data policy, governance, law, ethics. Those courses are missing for most schools, and that's an opportunity that IBM is working to help close with schools. Like I said, that's a fast-growing area, and these skills are going to need, every company is in need of these skills today, and they're hard to find. And it's something that IBM oftentimes is happy to provide as a consulting service, but still companies need these skills themselves. Next, data policy pros. So I talked a little bit about this, and there's a few schools that have pieces of the picture. So Dalhousie in Canada has got pieces. Syracuse iSchool's got pieces. And again, a lot of the jobs that pieces are similar, but again, the specializations, like you may be more interested in the life cycle of data. So what happens to my piece of once it's created to the point that we destroy it? Do we understand what's going to happen? Or is it something that this is a piece of information and the government requires me to keep forever, so I can't delete it? Or is it something, there's actually laws out there that force people to delete it immediately when a certain event happens. So Netflix actually got in trouble for this because they were not deleting customer data when they left Netflix. Turns out there's a government law that was passed in the 80s that required them to do that. Who knew, right? They didn't know it, but they got in trouble for it. Data privacy and security, that's a biggie. Data quality, we talked a bit about that in this morning's meeting. What does this data really mean? Is this useful data or is it bad data? Understanding that is a big part of it. Master data management is another big emerging area in governance that a lot of companies IBM sells a number of products around this. But the basic idea is to create a structure for data. And this is, the master data would be, as a simple example, here's all the products that I sell. And so we know that I have a product, it has this SKU, it comes in 5 different colors, 20 different sizes, and that doesn't change. But what does change around that data is how much is in stock at this store, how much is in that warehouse, how much is on the way from the manufacturer, how much is in transit, right? So that when you start structuring between master and then all the other pieces around it, it gives you a different way of thinking about your data. And then I covered the compliance with business rules, laws, and regulations is a huge, huge need, and we're going to see more of these laws being created as everybody wrestles with what do we do with data, what's allowed, what's not allowed. And then there's also a broader issue around policy at the government level about what should be the policies be, what should the laws be, how should the laws change to do what we need as society. Right? I think healthcare is a great opportunity for this because there's a huge side of one side that says we've got to keep it all private. But yet there's a larger societal need for it not to be private. Right? So how do we balance that? How do we make that work? And some people will say, we'll just de-identify the data. And how many people here understand the concept or heard of the concept of de-identification? How many think it's possible? Couple. So here's kind of the reality. So here's an example. So 80% of the population of the U.S. can be identified with 3 pieces of information that don't include their name, their social security number, or anything else that you would consider personally identifying. So if I know your sex, I know your date of birth, and I know your zip code, 80% of people can be uniquely identified with those 3 pieces of information. Right? This is hard. Right? So the more we try to pretend that it's possible to identify, it's actually amazingly easy to re-identify. So what got Netflix in trouble wasn't just that they were disobeying the law. That's what eventually what got them into trouble, as the fine print. But they had de-identified all this data to run the Netflix challenge. They were challenging people that wanted to see themselves as a career in data science, who could come up with a better algorithm to recommend better movies for what you want to see. So they took a subset of their data, took out all the personal information, and then put it out there for everybody to work with. Turned out they could re-identify that data how? IMDb. They go and look for similarities between people's reviews in the Internet Movie Database and what was in theirs. And bingo, we figured out who you were. Right? De-identification is really hard. And I think it's probably a research area, because maybe there are ways to figure out how to do it.
If I can, there's a famous story in healthcare of an MIT graduate student who combined the quote-unquote de-identified public employees' healthcare database with the voter rolls from Massachusetts and was able to identify Governor William Weld in the database by crossing over those.
Yeah, exactly. It's when you combine. That's where big data changes everything, right? Data you didn't think would ever get married together can be married together. And you can figure out correlations you didn't want made. And that also gets back to us as individual stewards of our own data. What do we really want to have out there? Right? There's things I said in the 1980s in internet message boards that I'm probably really happy that information is not out there right now, right? Because it kind of just disappeared. But now if I said something like that, it's going to get stored in the freaking Library of Congress forever. Right? All right. Next slide. Data architects, I think I covered a lot of this. It's really this is the chief data officer early in their career. And 2 different schools we're working with on that are Boston University and ITAM, which is kind of the MIT of Mexico. And I think these jobs are very much in big demand. It's not quite the job growth of some of the others, but I think it's going to be growing. Based on what I'm seeing in the market, we're going to see a lot more demand for these as well. And there are certain companies out there that are specializing in building these skills And the companies that I've seen doing the best job of that are actually the big system integrators that sit in India. So Wipro, Infosys, Tata, there's one other, the four big ones. And what they're doing, which I think is, it should be instructive all of us sitting here, is they hire, first, India has the best high school and college level STEM education in the world. So they have this huge pool of kids that want to study this, whereas we have this problem with kids don't want to study it, right? And so they have all these smart kids coming out with a master's degree in computer science or math or whatever, and that's their baseline. And then when I sat down and met with Wipro last month, they go, okay, so once we hire those kids, we're going to put them on a 7-year roadmap of continual education to turn them into these kind of roles. And here's what we're going to do from year 1, year 2, year 3, year 4. And it's the skills and having those skills and building that up is a true commitment on their part. And I don't see that. Not even at IBM, I don't see that. Right? I think that is instructive to all of us from a competitive point of view of thinking about this, right? It's that ongoing education and actually having the structure in place to make it work. Next. All right. So this was the help me build a slide one. And I don't expect it really to do it here, but I would love to build a slide that for health informatics that had OHSU in there, the logo, and hey, we're working with IBM to address this. Understand what are the key skills, the common titles, and a description of what these are. And because this is not an area that I'm personally expert in, but I'm hoping to learn from everyone here today. So I think that there's a lot of opportunity in health and bioinformatics because there's so much public good that can be done in these fields. And just having a better explanation of what these are, and I could put this in the hands of my peers across the IBM company so that when they're working and talking with people and understand these are the skills that people are looking for, what they need, and we can get a discussion going about, okay, so this is what we think the market needs, this is what you're teaching, how do we close the gap, right? And in OHSU may not have any gap, I don't know. But a lot of schools when I talk to and all these other ones, a lot of them will have pieces. But when we actually look at what the market needs, what IBM needs, what our customers and partners need, they need this, they're delivering this. All right, so how do we close that gap? All right, any questions? So the rest of my talk, I'm going to just go over a quick overview of some investments that IBM is making that are available to anyone. So I'm going to go through a bunch of these quickly. Some of these I know a lot about, some not so much, but I just wanted to make you aware of them. So let's go to the next slide. So we've created an analytics zone, and it's got a community section in it. This is run by our business analytics business unit, the Cognos and SPSS, if you've heard of those technologies. And you can go in and learn about and interact with people that are using these technologies or how they can apply it to real-world business problems. This is free. Next slide. Another one, Developerworks. So if you're a coder or any kind of a practitioner and you need to get information about how do I get this done, and especially if you're using IBM software, but we do a lot of it around open source as well. And we just created one. We announced this at the beginning of April called the Big Data Zone. This is all about the technologies that are emerging around big data. So streams, Hadoop, Mahout, all the different pieces that are part of that. And IBM has a number of product offerings now, as well as a lot of our partners. And this will be the place to go and get, learn. Most of our traffic to the site is actually through Google. We put the content out, and then as long as the keywords are right, people find, that takes you to the content, and there's an article, and that helped me solve my problem. And we have forums, we have a lot of other resources available here. Next one. The other one that we've done in partnering with a number of organizations, we've created Big Data University. So this is a site where you can go and you can sign up, and then you can start taking online short courses, they're not very long, about Hadoop, and all the different components around it, for example, and just start getting started with it. And the code is available in the Amazon cloud. That costs you a little bit of money. You can put your credit card in and start using it, or you can download it if you've got a pretty capable PC. The reason I say that is the Hadoop stack is fairly involved, and to really use it, you need a pretty tricked-out PC. So the typical PC with 4 gigs isn't going to cut it. You want something really well configured if you really want to use Hadoop on your own personal computer. So this site, I think, it was from yesterday. We have 80,000 people so far have signed up to take courses there. And so by the end of the year, we're easily going to hit 100, probably 125,000 or more. And that's just another great way just to get started in the basics of using this technology. But it doesn't really cover all the other things I talked about, right? It's the technology itself. How do I use it? How do I do things? But not the bigger picture of these different emerging fields. Next slide. DataMag. So this is one thing that my team does. We publish IBM DataMag. And IBM DataMag is a great place to come to learn about our products, of course, but also a lot of thought leadership content around governance, big data. You can get a nice view on how IBM thinks about these topics and help you come to your own conclusions. This was a snapshot from last night, so you can see the title article right now is The Emerging Role of Chief Analytics Officer, which is another path I didn't even go to in my presentation. Because there's a whole path, if I took the business side of it versus the technology side of it, I could have a lot more slides. We have just a lot of great content in there, and frankly, if you wanted to write for this magazine, we don't pay anything, but if you wanted to write and you wanted to get your name out there and start building your own personal resume, right? Get in contact with me afterwards. I'd love to, if you had something that relevant to this audience that you wanted to write about, I'd love to help you get published. And it's online, so we used to be in print, but print's kind of dead. So, quarterly print magazine, you're kind of limited number of pages. The beauty about online, I don't have any page limitations. When the content goes up, it goes up right away. And my print magazine was read by people in the U.S. This magazine, last time I did a Google Analytics search, my readers come from 172 different countries. So all of a sudden I went from a very narrow footprint to a global footprint just by putting it online. Next. So this is the other one that's relevant right now to the faculty in the room. We have an academic initiative that gets you access to our software, either for download or to run through the cloud. So the cloud program requires another request to get to it because we have a limited ability to pass it out right now. But the idea here is that you enroll as a faculty member, you agree to the terms and conditions, which I think are pretty straightforward, and then you become a member of the academic initiative and you get access to the software and to shared curriculum that might have been created by IBM or shared by other faculty members from around the world. And this is a great way to help us and all work together collaboratively to help build the skills that are needed in the broader market. Next slide. So here's the other one. This one is too late for this year. But we opened up a Big Data and Analytics faculty grants program focused on curriculum. And we had 92 proposals. And we opened it up for, I think, 45 days. In that time, we got 92 proposals from 75 different universities in 23 different countries. And here's a list of the different programs. A lot of comp sci and information science was at the top, but business schools, math, stats, operations research. And a lot of these schools are big-name universities, Oxford, Carnegie Mellon, but also a lot of smaller schools, too, applied, ones that I wasn't really all that familiar with, or overseas schools that I just wasn't aware of. And a lot of phenomenal proposals. I wish I had a lot of money to give away. Because given all that interest and the quality of the proposals, we could really foster. Right now, I think we're probably 15 of the 92 are going to get an award from IBM. And so for OHSU, I want you to be aware, because when we open this up again in early next year, it'd be great for you to be competing for some of those dollars as well. All right, next slide. This is not an easy one to read, and this is for the faculty as well. So we've just announced yesterday the Big Data and Analytics Educational Conference. It'll be in Las Vegas on November 2nd and 3rd. It's a weekend, immediately preceding IBM's biggest customer conference. So we're going to bring 14,000 people from around the world to Vegas to learn about big data and analytics for a week. And on the weekend, we're putting together a 2-day event just for faculty. The first day will focus on tutorials about how do you use the software. So if you want to use our big data stack or SPSS or Cognos or perhaps even Watson in your courses, how do you do that and make it easy? The next day, it's an event put on by faculty for the faculty. So we're hosting it, but it's your peers that are around the world that are going to be providing the content with a peer review panel. And it's all a discussion about how do we do all the things that we've just been talking about. How do we close the gaps and get the right programs out there? And I'm really excited about that because I think there's a lot of opportunities, a tremendous interest, as from those 92 people that submitted proposals asking for money to help build curriculum. And so I gave Deb a copy of the call for papers, and she's getting it out to people. But if you didn't get it, just ask her for it, or you can ask me for a copy as well. All right, next slide. We got 2 slides on the visualization initiatives coming out of our business analytics team. So one is called RAVE, and it's a kind of a core technology ability. And I'm not expert in these at all. I just wanted to provide them as examples. So RAVE and the one after it, Many Eyes, I want to just show them that as well. Are just 2 online data visualization sets of features that IBM is making available for people to work with. And if you're interested in the visualization aspects, I encourage you to go to these sites and to dive in to see what's there. Because I think visualizing data is a huge need, and understanding what really works and what doesn't, I think, is hard. I've seen a lot of visualizations. People go, oh, it looks great, but I sit and stare at it for an hour, and I walk away, I don't understand what you're trying to tell me. So I think there's a lot of opportunity to use this type of technology with the right skill to be able to convince people of things. But I don't think it's easy. Let's see, what's next? I think we're going to Watson, yeah. So I've got 4 slides here on Watson. So I'm not an expert in Watson, but Watson is being applied to healthcare now by IBM. And so it's not just, can I go win Jeopardy, but can I use the same technology that was used to win Jeopardy to help doctors and nurses make better decisions? I think there's huge opportunity there, and so does the Watson team. So it's all about a lot of different technologies coming together: temporal reasoning, statistical paraphrasing, geospatial, reference text, answers. A lot of things that they can bring together to, using, in this case, patient data, to come up with what's a better answer for what I should need to do and what might be my next step space. So you can see all that history from across a lot of different patients and help a doctor more quickly come to a treatment plan, for example. Next slide. I guess this is a little bit automated. Sorry. Just keep going. All right. So it's natural language and human speech. It's evaluating hypotheses and adapting and learning. Right. That's what's really cool about it, is that it's not just a search engine. Right. It's the fact that it's got some machine learning type ideas and cognitive algorithms built in, so that it's learning from itself all the time and learning how to create better answers. Next. So here's an example at WellPoint. So I think they're using Watson Insights 90% of the time because it's so much better than what they had before. I think that is really cool. And they've been aggressively passing it out. So far they've got 600,000 pieces of medical evidence and 2 million pages of text from medical journals, all brought into together the system to be able to combine all these different data points to help them make better decisions, right? So then on this pilot, they brought in a lot of test case scenarios, a lot of real-life cases, and then 15,000 hours of hands-on training mostly with the nurses, helping feed information into Watts and to help teach it, right? I think that's pretty amazing what this type of technology can do in an area that's a very important societal importance. I think I might have one more slide. So I think I talked a bit about this, right? Deep linguistic analysis. It can go in and understands many more specific attributes of patient symptoms, from physiology, family history, genetics, right? All of these. And classical approaches are relied on very explicit rules. In this case, they're talking about the rules are not so brittle. That because they've got all these different things together, they can kind of figure things out better and draw better insight and be more current, right? Because they're immediately feeding in all the latest research, which there's so much of it being generated, there's no way any one researcher can be up on everything else. So what I like here is it's kind of the closing statement, right? New disease coverage and training is accelerating, building on prior knowledge and linguistic adaptation. So I'm not an expert in Watson, but I just wanted to bring this to you as an example of how an IBM invention is being immediately applied to something of very great importance to all of us. So that's my talk. I really want to take questions. I want to learn from you in the rest of this time, and I appreciate the opportunity to come.
So we have at least 10 minutes for questions. Please remember to push down the button.
Anyone?
Hi, my name is Benita. I'm a first-year student of Clinical Informatics with Dr. Bill Hirsch. My question is, like, somebody who is not comes from a computer science background, how can they get an entry into the analytics field? What are the skills that you propose that they learn?
So they're coming from computer science? Not from computer science. I think if you want to get started and you don't have a computer science background, you absolutely are going to have to be able to have the mathematical skills and ability to understand all the different aspects of stats and all those different 4 categories of analytics that I talked about. You don't have to be a computer scientist to do that. The computer science aspect, though, is going to be needed if you really want to be on the forefront of data science. But can you be in analytics and use applied analytics without that skill? Absolutely. Right? But either way, you're going to need some pretty deep skill that's based on a strong STEM background, right? If you don't have that, it's going to be really hard to get into this.
Hi, your growth rates are definitely impressive, but what's the end? Are you starting from a base of 1 or 200 for a chief data officer?
Yeah, those are good questions, and I didn't pull that data from Indeed. So they're not huge, but they're definitely quite a few. But we can talk about that later. I don't have the data pulled.
For companies you work with, what percentage would you guess, just on a gut feel, have a data officer?
10%. Or they may have a different title for them. They might not be using that title exactly, but people that come to work every day worrying about those things, it's definitely growing. Anyone else?
About some of these roles, do you think that these roles are in addition to the various chief technology, chief medical information, and other officers that we have, or do you think that the needs and skills need to be kind of reshuffled and partitioned into these different kinds of titles and these different roles. So I guess the basic question is, do we need additional officers to fulfill these roles because the roles we have are still current, or are these skills that should be combined with some of the other roles and then kind of maybe redistributed and retitled?
Yeah. No, that's a really good question. And then in certain fields, it may already kind of have the roles. Just they have a different different name to it. But what I think is going to happen, has to happen, is just as we are all climbing this ladder, and I think what you're going to see is right now the core skills that we need aren't quite there, but schools are rushing, especially on the analytics side, to build those skills. And over time, you're going to see the basic core knowledge of expectation rising. And the higher it rises, the more there's going to be the need for kind of these people that can really think at an organizational level about how do we manage all of that. And one thing that we've seen a fair amount that IBM's helped create them is we recommend that large companies or large companies that can afford it, that they create center of excellences around analytics, around warehousing, big data. And oftentimes, it's really hard to find a person that can do these jobs, but you can build teams to do it, right? But you still have to have somebody that can run that and understand the broader scope, but that's going to come over time. And you start thinking about what are all the different things that might be on a data science team, right? So you may end up with the data steward and data policy guy. You may end up with somebody that knows that industry you're in really well, bringing industry skill to the table. There may be somebody that bringing simply project management skill to the table, right? So I think the teaming approach is how most companies and organizations are going to solve it. And at the educational level, there's been a lot of discussion about, at the master's level, what are you trying to create? Are you trying to create oftentimes you heard the T-shaped individual, where they have this core knowledge and depth of knowledge and skill, but then the T is actually teaching them how to work with other people and how to affect change. And I made an argument in a speech last year that maybe what we need is the pie-shaped individual, where that third leg of that is actually more applied knowledge to the industry that you're in, right? That can actually, it's not just that you know how to do the technology really well, and it's not just that you know how to work with other people, but you know actually how to apply it to a particular problem set and have deep skill in that. And I think that's probably not really realistic, so I think the team approach is really more likely to be the answer.
Quick follow-up. Have you seen, where would that team live organizationally? Or I guess in the successful situations you've seen, where have they lived? Who have they been under in terms of structure?
Yeah, well, I think if the more you try to hide it, when some companies do that, it's like it's a group over in the corner, the less likely the company is going to be successful, because data as strategy and the impact of bad decisions, or even the impact on negative things on your corporate reputation, are so dire that you have to elevate that organization to sit and be in a place where they're not in IT, they're not in the business, they kind of got to sit in between. And that's why we're seeing these new emerging roles where these titles are actually in the C-suite, right? In some companies where it's analytics is uber important, there's a chief data scientist sitting on the board, right? I don't think a lot of companies won't need that, but they certainly will have a chief data officer that has those people working for them, for example, or a chief analytics officer. And I think it'll be interesting to see, will the chief data officer and the chief analytics officer, will those concepts diverge and be separate, or will they come together and be one? That's to be seen.
A few years ago, there was a big push. It seems to have kind of died down for this notion of professional science master's degrees, PSMs, and there was actually a push in Oregon, and we were a little bit involved in the discussion. But so you've kind of indicated that there's lots of different fields, information science, informatics, whatever, that can feed this. But then there's also the issue of the type of the degree. You know, the PhD. You know, one of the problems is that a lot of science faculty want to create people that look like them and become researchers. And there's a complaint. In fact, at the National Institutes of Health now, there's a big push towards looking at other careers for biomedical scientists besides academic faculty. So is one possibility almost like the data equivalent of a professional science master's that not only teaches people the hard science, but the soft skills and some of the other kinds of things that enable them to function in industry environments?
Right. Yeah, no, I think you're absolutely right. And so we need an ecosystem that covers all of those, right? So if we don't have the strong research basis, then we're not going to keep advancing, right? But we also need to have the skill that actually able to apply this to meaningful problems. And right now we're short on both, right? And like I said earlier, right, on the business side, the business schools it's hard to find, it really is hard to find a business school that doesn't already have an analytics program that they've announced or isn't planning to announce one soon. And that's not really going to be a problem with finding people with the business skills to actually understand how to apply analytics to their business. But when I look at those programs and a little bit closer, some of the things I talked about are not really prevalent yet. So, data as strategy, right, oftentimes is missing, right? So that broader picture about how do we strategically manage data, or can I create a new company that's solely based on managing data, right? Or the whole data policy area, for example, another one that I think is going to be a gap for a long time. And it's something that has huge import to all of us, because if we do that wrong, and we get embarrassed, or you end up getting arrested, or right, and you don't want that. So, anyone else back? Yeah, absolutely. And what I'd like to see, I don't know that company personally, but on the law side. So we've created this opportunity where two companies own all the public data and access to public data, which is the result of all the different judicial decisions and things, right? And there's certain things like that where I question whether the right thing going forward is to allow a private company to own access to public data. And so I think there's going to be lots of interesting policy decisions that have to be made, right? So should government even have ever allowed West to exist, right? I mean, they're an IBM customer, so I got to maybe not watch that. But there's a reality, though, that is something that's open, to me, that's open data. That's what government is about, right? Providing better services to our citizens. And then if you want to create a service on top of that, that's cool, right? But you don't actually own the data. I do. You do. We all do. Anyone else?
I was just going to say that's especially pertinent in healthcare. Like, for example, pharmaceutical clinical trials. I mean, those are people who take part, yet that data is all, at least our approach to it right now, is all proprietary. But there's actually a lot of conversation about making clinical trials data more open, although by the same token, you get into the privacy issues.
Yeah, I think it's very significant, right? And it's something that we're going to all have to wrestle with, right? It kind of reminds me of the conversations in the old Star Trek, right? Good for the one or good for the many, right? Those are the decisions that we as a society are going to need to decide.
Well, I think at this point we'll call it quits, and
all right.
Thank you again for your...
Yeah, so the slide so as I'm leaving, if you want to follow me on Twitter or at least see the things I talked about, Brand Steve. So my name's not Brand. So Brand has to do with my marketing persona, so like Brand Steve. So, and you can follow me, or at least you can just see the access to the all those different things in the last day, the volunteer opportunity in Portland schools, how to take advantage of the call for papers, and anything else that I'm talking about related to big data. So thank you.